Okay, so today we're going to be looking at 8.2, proving triangle similarity by angle. So what can you conclude about two triangles when you know that two pairs of the angles are congruent? Well, one of the things that you conclude is if they're congruent, then the other one is also. So it's why it's called the angle-angle similarity theorem. And the reason for the similarity instead of congruency is because the sides could be different. You could have different sides. The sides could be similar sides. The angles can be congruent, but the sides can be similar. So we're going to be looking at that. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Why? Because if these two angles are congruent, and each triangle has 180 degrees in it, well then these are congruent too. So all three angles are congruent, but it doesn't mean the triangles themselves are congruent. It just means they're similar, because you can see you could have three congruent angles, but you could have completely different sizes when it comes to the triangles, a small one and a big one. That's why the triangles themselves are just similar. So determine whether the triangles are similar, and if they are, write a similarity statement. Explain your reasoning. So if you're trying to figure out if something's similar, notice this is 90 degrees and this is 90 degrees. This is 75, but I don't know what this is. So in a 90-degree triangle, you can take 90 and subtract the other angle to get that. And now you'll see you have a match. And vice versa, this is 75. So yes, triangles are similar. Because angles are congruent, and therefore ABC is similar to EFD. Okay, so you can say they're similar, and you can actually write a similarity statement. So let's check this one out. So determine whether the triangles are similar. If they are, write a statement about it. So if you look at this and you add these two together and you subtract from 180, you'll see that this is 106 degrees and this is 34 degrees. Well, in order for these to be similar, they have to have at least two measurements be the same. They only have one. This is off by 10 degrees and this is off by 10 degrees. So they only have the one that's the same. So no, triangles are not similar because angle measure are not congruent. All right. Show that the two triangles are similar. Well, if I have perpendicular going here and here, it also means I have something called corresponding angles, and we've talked about that in the past. If you have parallel lines, this becomes your transversal right here, and these are corresponding angles. And then this becomes your transversal for this one, and these are corresponding angles. So they are congruent. So do I have two sets of congruent angles? Yes, I do. And it's because AE is parallel to BD. Angle A is congruent to angle B. And angle E is congruent to angle D. So therefore, triangle ACE is similar to triangle BCD. Okay. Show the two triangles are similar. So again, parallel, transversal. So that means this angle is congruent to this angle by alternate interior angles. And This angle is congruent to this angle by alternate interior angles. Remember, if you were to extend this, you would be like little bow ties. So you have parallel things happening in the other direction as well. So you could have used it in the opposite direction as well. So opposite angles are congruent. Angles are congruent. So therefore, triangle PQS is similar to triangle RSQ. Okie doke. Let's try it. You ready to try it with actually making a drawing? Not as hard, or not, well, I wouldn't say not as hard, a little different. So determine if it's possible for these two triangles to be similar given these measurements, and explain your reasoning. So if you have a triangle, the first thing you should do is give yourself a drawing, because when you draw it, you can actually see what you're doing. So I just draw triangles that look similar to each other, and then I label them. So HJK, H I know is 100, J I don't have a measurement for, K is 46. Excuse me. And then PQR, so PQR, this is 44, this is 46. And what I want to find here are these angles. This one here, I don't know what it is, and this one here, I don't know what it is. So you can do 46 plus 44, so that is 90 degrees, which means that this is 90 degrees. And you have 100 and then 46. So 46 and 44, again, 0, 90. So that's not going to be right. It's actually going to be 36. Nope, 34. I'm sorry, 34. I'm going to confuse you now. So this is 34 and this is 90. So are they similar? No, they're not, because 100 plus 46 plus 34 is 180. So 100 plus 46 plus 34, and I get 0, 1, 8, 1, and it's 180 degrees. So I got a no match here. And what I mean by that is these don't match. So it's not similar. Okay, one more example. I'm going to try to zoom out for you on this as best as possible. Use the diagram left to complete the statement. The measurement of EGD, measurement of EGD. EGD, this one right here. What is it and how do we find out? Well, here's the thing. You got this right here is 90 and 63, right? And if this is 90 and 63 and this is 90 right here and this is 63 right here, I find that by subtracting. So I get 27. 90 plus 63 plus 27 equal 180. EGD. 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 Didn't I just do that one? Oops, I did the wrong one. AGB was right here. By the way, that's also 27. I did them backwards. You'll forgive me. So this was supposed to be this one, and this was supposed to be that one, but that's okay. They're both 27, and I explained why. By the way, these are also vertical angles. So if you take a look at the whole angle itself, this whole thing and this whole thing, those are vertical angles. So they would have been congruent. So BCG, 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 BCG. So if this is 27, then this is 27. It's getting split. So this would also be 63. AB, if this is 3, then AB is 3. FE, the whole thing is 3. So the whole thing is 3. So this is going to be half of that. ED, same thing. And DGF. So take a look at those. If you're writing a similarity statement for all of the triangles that are congruent to each other, you would have EFG, EDG, BAG, and BCG. And those are all similar. A couple of them are congruent, but similar. Okay, that's it for this lesson. It's a little bit shorter than the last one. Yay! And the next one should be short as well, because this is somewhat stuff we've talked about, but at the same time, if you have any questions, please let me know.